Okay, physical science time. Today we're going to talk about Newton's laws of motion. We're only going to have a chance to talk about this briefly. We'll probably have two videos. We'll do one today and one tomorrow, I would guess. I would like to kind of today review what, in my opinion, you should know from 8th grade science, which we did last year because you were in 8th grade last year. We're going to review what the concepts you should know, and then we'll kind of go a little bit deeper into some new concepts and into the math a little bit more tomorrow. That is my current goal. We'll see how that works out. Okay, so Newton's laws of motion. Let's talk about these, and let's talk about them in the order that Newton himself relayed them to us in his Principia Mathematica in 1638 or something like that. Put in the comments whether that was right or wrong. What is going on with the video? Comments are disabled for this video. Thank you, Gunnar. Well, I don't know why it won't let me go into picture-in-picture. Wasting my time. Killing me? Oh, there we go. Ow! And now I ruined my TikTok lights and everything. Okay, we're not having a good time so far, but it's going to get better. What is Newton's first law of motion? Someone say it out. Raise your hand first, and then I will call someone. I'm going to have Gunnar do it this time, Aaron. That's not how it usually starts, but I'll let you continue. I'm not. This is. Okay. I will accept that. I'm going to pretend you said the right thing. That was just. It was funny to me that. I'm sorry. This is giving me true mirth, and that's why. I'm not trying to make fun of you, young man. It's funny to me that you would raise your hand so rapidly, and then when I call on you, you're like, well, shouldn't have raised my hand. Anyway, an object. Let's start it with like that, and then let's go from there. An object in motion. Thank you. Yes, tends. I like that better. Who said that? Kesslin Ramrock. An object in motion tends, Fate Ramrock instead, to stay in motion and an object at rest, we already talked about this one even this year, tends to stay at rest unless, as you know, acted upon by an, we could put unbalanced. In fact, we're going to put unbalanced. What's the other word we could put instead of unbalanced that we had learned about in the last chapter? Weird. No. Uh-oh, this is, no. We're going to get to that in a second. No, what do we call it? A force that is unbalanced. It has a net force. I am going to put unbalanced.
Wait, you said an object in motion tends to stay in motion and what?
An object at rest tends to stay at rest unless acted upon by an unbalanced net force. And then, as Taylor correctly points out, the one word that applies to this law is inertia. The Latin word for laziness. 2. Who remembers 2? We most often express this one as an equation, which we will talk about, and we'll talk about it more tomorrow. But who remembers what 2 is?
What's the word after
Acted, probably. And unbalanced. You did your vocab though, didn't you? Yeah, an unbalanced force causes an acceleration in the same direction as the unbalanced force. We usually express this one as an equation. F equals ma. Your book provides it as A equals F net over m, and that's fine too. Hey, and we're going to talk about this tomorrow, but do you see how these two things are the same? F equals ma is the same as A equals F over m. Do you see that? You guys know algebra, right?
Yes.
You guys are in the process of knowing algebra, right? So you can see that F equals ma is the same as A equals F over m, because what have we done here? What have we done to F equals ma to make it into A equals F over m?
You gotta divide.
Yeah, we divided both sides by the mass. We divided both sides by the mass, giving us A equals F over m. The m's on the ma side reduced to 1.
See, I still need to go to English cuts, so people still can't
Oh, here, let me start writing in print. I'm sorry. I was just having a good time. 3. You should know Newton's third law. Everyone, you learn Newton's third law in 6th grade, and it's like, or maybe like 4th grade, and it's poetic enough that you just keep it memorized. Because what is it, Fate? Let's start it this way. For, okay, I'm sorry, I am going to start writing in print. For every action, there is an equal and opposite reaction.
I remember those words. I just don't ever remember that.
This should all be review. None of this should not be review. You should know this. I'm going to trust that you know this, at least at this level. You should know the word inertia. You should know what that means. We did talk about this in the last chapter. This we will talk more in depth about tomorrow. An acceleration in the same direction as the unbalanced force. And then for every action, there's an equal and opposite reaction. I don't like that. That was chaos.
Did you tell the viewers what I just said?
No, the viewers will forever remain in the dark as to what you said, young man. Your book then talks about the ideas of friction and gravity. Let's talk about those real briefly. This should be review. Friction, gravity. Friction applies when two surfaces are, sliding past each other. Opposes motion, contact force, meaning they have to be touching, and what kind of when you rub your hands together, what kind of energy is changed? Kinetic energy, the energy of movement, is changed to heat. Yeah. So kinetic energy. I should write that out instead of abbreviating it. Sorry.
Same with plastic.
Thank you. That's very astute.
If you move plastic,
Kinetic energy to thermal energy. So heat is generated. Well, the energy is transferred from kinetic energy, or transformed from kinetic energy to thermal energy. The objects have to be passing, and there are different kinds of friction. There is static friction. The static friction is the thing like if I have my podium ever so slightly tilted like that, do you see that? Yeah. Static friction is what's holding it in place. Static friction is holding it in place, meaning they're staying. It's staying. Static friction is what causes something to stay put. So like if you have a very slightly sloped surface, but you can still place something on it, that's static friction holding it there. Static meaning stay put. Whereas sliding friction is like when you're actually sliding friction's going on. There's also rolling friction if something is rolling. And there's also fluid friction, which is in the case of aerodynamics.
Most friction is
I don't know. I don't.
most friction used in the world.
Well, friction is almost well, I was going to say it's not usually used, but it is. It is. We do use friction. I don't know.
One of those three
That I had to guess was the most like universally prevalent. Probably the fluid friction. I would guess there are more fluids in the universe than there are. I don't know. I don't know the answer to the question. And furthermore, cars. Yeah, good one. Okay, but fluid friction including air resistance. Your book has a discussion about air resistance that is in the vocab section, or after the vocab word for air resistance, that you really should read. And then gravity is the force that attracts all massive objects, to all other massive objects. What do we call the force of gravity on an object? No. What do we call the force of gravity on an object? There's a word for how much the force of gravity is pulling on something. No. You had to talk about it in your... No, you're getting closer, though. It's not. Mass is how much... Let's write this. I should probably say... I'm going to write over here. Mass is how much matter an object has. How much matter in an object. The other thing, how much gravity is pulling on you, or how much gravity is pulling on that object, is another property called... No. Weight. Weight please write this down. Weight is how much gravity, I just abbreviated grav, pulls on an object. That is still visible on the video, so that's good. But I did kind of run over because what I wanted to write here is that there's an equation for this. Oh, this is getting so tiny. W. What do you think the W is going to stand for? I'm going to have to start this whole thing over because this is way too small over here. I really ran out of room. No one's still using Newton's first law over here, are they? So I'm going to start over. We're going to scroll everything down one. Is anyone still writing down any of Newton's 3 laws that we have written here that's taking up 99% of the available space on the board? Okay, I'm going to erase all of Newton's 3 laws at this time, and we're going to continue our discussion about weight and gravity in the big spot. That seems reasonable. This is still review. I just literally talked about all this with 8th graders the day before yesterday, and so I know you should know this. I don't know that you know it, but I know that you should know it. So weight is the force of gravity acting on an object. Very simply, are mass and weight the same? No, they're not the same. These things are not, I still have mass written over here, not the same. They are not the same. They are related. The more mass an object has, the more weight it has in any given set of gravitational forces. The more mass an object has, who has more mass? Me or my eraser? Probably me, but that's really mean. You guys shouldn't call me fat. That's super mean. I have more mass than my eraser, and I also, because we're both in the same, well, we're not in the same exact place, but because we're both on Earth's surface, we also have a comparable weight. My weight is more than the eraser's weight. Weight is the force of gravity acting on an object. W equals mg, where, hey, look, it's going to be an equation. What do you think you should probably do with this equation? Freshman, write it down. That's a good first step. What else should you do with this equation? Okay, but what else should you do with this equation? What are you probably going to have to do with this equation? Practice it, yes? It's going to be on the test. Memorize it. Memorize this equation. W equals mg, where W is weight, measured in, we'll talk about that in a second. M is mass, measured in usually kilograms. And lowercase g is the acceleration. Have we heard about acceleration before?
No.
Yes, we have, Gunnar.
Due to, can you guess?
Ball.
Due to what? Acceleration due to what specifically?
Gravity.
Gravity, yeah. Acceleration due to gravity. So, and not only is there a unit for this, what's the unit going to be for sure? Since it's acceleration, it's the SI. Meters per second, no, meters per second squared. But also on Earth's surface, there's a set value too, not just a unit. 9.81 meters per second squared. You need to have that memorized. What do you need to do with this? Memorize it. And what is this? Acceleration due to gravity on Earth's surface. 9.81 meters per second squared. So then if we multiply, if W equals mg, our unit for W will equal our mass unit times our gravity. So kilograms times meters per second squared. This whole thing is the unit for weight. But we have an abbreviation for this. Look at this abbreviation. What is that? Newtons. So we abbreviate this whole lump, kilogram meter per second squared, because it is a kilogram times the meter per second squared, as a Newton. And the Newton is the unit for weight. It's also the unit for any force.
Okay, can I go back to my...
No, I have to get through one other thing and then we'll talk about it. And then look at this equation. F equals ma.
Force equals mass over acceleration.
No, not mass over acceleration. F is force measured in newtons. M is mass measured in, guess what? Kilograms. And A is acceleration measured in, as you know, meters per second squared. Do you see a similarity between these two equations?
Oh, yeah. Right.
Where we have weight is measured in newtons, m is mass, and g is acceleration due to gravity measured in meters per second squared. And this one is force measured in newtons, mass, and acceleration in meters per second squared. These are the same dang equation. It's just that this one is specifically measuring the force of gravity. This one is specifically measuring the force of gravity. And this one is measuring any old force, including gravity. What do we use to measure forces? What unit measures forces in the SI? Newtons. And what base units is a Newton equal to? Kilogram times meter divided by second squared. So kilogram times meter per second squared. Questions about the equations for, there will be 2 more equations in this chapter. We'll talk about them tomorrow. Or questions about friction and gravity. Or questions about your review of Newton's 3 laws. Really, every single thing here should be a review from 8th grade. Does anyone have any questions?